gathered on the traditional, ancestral and unceded territory of Musqueam people. And that gives us great privilege. And we'll reflect on that through today's presentation. So we've got two presentations today, both on the topic of climate, and both from Simon Donner's lab, which is the Climate and Coastal Ecosystems Lab. So both talks well into the climate bit rather than the rest of that phrase. So we're going to start with Ted Scott, who is a second-year PhD student from geography, supervised jointly by Simon Donner and Rachel White. And he's going to talk about climate risk in the sense of temperature. And Ted already has a PhD. He's also worked as a data scientist at Microsoft for about a decade and a half, and has also worked as a high school teacher teaching maths and science. And then 2 years ago, came to do a PhD at UBC. That's the intro, Ted.
Thanks, Vicky.
Yay.
Well, that was what I was going to begin with. Let me know if I zipper make weird noises. Well, thanks everybody for being here. Yes, I'm going to talk about summer. Well, Vicky gave that intro, so that betrays maybe that I have a few more decades than some people, but all of us have experienced a couple decades of summer now. And if you're like me, perhaps you have noticed that summer now feels different than when you were a child, and that summer definitely seems to be changing. And so I'm going to talk about that. And you're not bonkers to have noticed that. Like, summer is changing dramatically in our lifetimes, and that matters. Like, what is happening to summer matters because of the intersection with a whole lot of other phenomena. Extreme weather, the hydrologic cycle, biological life cycles, economic productivity, tourism. A lot of economy is driven by seasonal cycles, but also human and ecosystem health, and energy demand. You know, if summer gets warm, we need to cool things off. So big impact. Now, recently, this hit the news, and actually hat tip to Vicky for pointing out that there was some relevant news for me to include. You might have caught in November that the city of Guangzhou in southern China, the Guardian, South China Morning Post, they were, well, in the spring, they were talking about how summer started really early. And in November 14th, the Guardian and some other sources were talking about how Guangzhou was still in summer based on their definition, which is as soon as you have at least 5 days above 22 centigrade, you're in summer, consecutive days. And then it had been staying up there. And it had been staying up there for 235 days already as of November 14th. And it did stay there a little longer, but if you search for the news about the city, I couldn't find an update on like still summer, or anything. But the point is, summer has changed dramatically in some locations. And that definition of what is summer is specific to the meteorologic service in that area of southern China. So we can't just use Guangzhou's definition. We have to agree on what summer is if I'm going to look at the changing summer globally. We could just say it's the warmest summer of the year, but that's not particularly precise. So there are kind of 3 standard definitions for the seasons. Astronomical, based on sort of orbital position, and that gives you a summer length of about 91 to 93 days based on solstice to equinox time frame. There's a meteorological definition where you just say it's these months or it's these months, but those are different for the northern hemisphere and southern hemisphere, and so that's not universal either. So just like what Guangzhou used, where they say above 22 degrees, that's a threshold. I'm going to use a threshold, but I'm going to derive that threshold by taking a baseline period of 30 years and then pick a percentile. And if you're above that, it's summer. If you're below that, it's no longer summer. So I'm going to use ERA 5 reanalysis data for doing this, or I did use, and I'm using air temperature, so surface air temperature, 2-meter temperature at a high spatial resolution, 0.25 degrees, that's about 31 kilometer grid size. And then I'm going to use a 3rd-degree polynomial and fit my temperature time series over the course of the year, and that'll let me get clean transitions above or below the 75th percentile, which is the standard definition if you use a percentile as your threshold. 75th percentile, the warmest quarter of the year. And my baseline is 61 to 1990. So what does that look like? Well, here's an Earth with approximately, 1 million grid squares. And then that blue curve jiggling up and down is the temperature time series from 0 to 365 days. And then my 3rd-degree polynomial would be the red curve fitting it, and the dashed line is that 75th percentile threshold. And so when I'm above it, I can easily pick out where summer is. And then I can define, here's where it started, here's where it ended, here's how long it was. In this sort of cartoon example, this summer started on June 10th and ended on October 3rd, using that. And I'm gonna look at 61 to 2023. When I did this, there wasn't enough 2024 data. There still isn't, but we're almost there. And I'm excited to add that. So what do we expect? We expect fast remote. No, we expect longer summers everywhere. And previous studies for land in the mid-latitudes, northern and southern hemisphere, have found that summers are getting longer at about 4 days per decade. And that is up until about 2012. That's what the prior works have covered. The ocean, which hasn't been studied separately for this, but we do have some guides that because of the ocean high heat capacity, it should take a little longer for it to warm up, right? And then it'll hold on to that temperature longer before it cools off. Also, we can look at coastal margins separately. And so those are going to be moderated by the ocean that's neighboring, but also impacted by the land and regional patterns. So these are sort of new areas to this line of research, along with the prior works up to 2012 for mid-latitude land. So what do we find? Well, we find that summer is getting longer. Just like I said, our human experience is that summer is getting longer, and it is. So this is a plot of average for mid-latitude northern hemisphere summers from 1961 to 2023, and then length in days. Blue colored is ocean, and brownish red color there is land. And you can see that from 1961 to 2023, the overall trend is increasing in summer length. We can look at the same thing for the mid-latitudes in the southern hemisphere. There's a lot less land in mid-latitudes there. And so this kind of overlap between ocean and land over the same time frame, but a general increasing trend. And then if you were really zooming in on here and noticed, prior to about 1976 or so, summer length actually appears to be decreasing or flat, and then takes off. But we can fit a linear model to that, and we see an overall increasing trend of roughly 6 days per decade for either northern or southern hemisphere mid-latitudes. And that seems to be about the same for land or ocean. If we zoom into 1990 to 2023 though, so here onward, we see that the rate has increased substantially relative to those. And so that is alarming and dramatic. I said coastal areas should be kind of in line, but probably between ocean and land, and green is coastal areas, and that is exactly where it falls, in between the two, almost smack dab in the middle, actually. So summer length changes are not, those were averages, latitude, average weighted for the mid-latitudes, but it's not universal. There's definitely regions where summer length is changing differently from others. And you see those are colored here. So anything that's blue, summer's actually apparently getting shorter, whereas red, summer's getting longer. This is an anomaly. map. So this is if I take my baseline period, 61 to 90, and I subtract that away from the 1990 to 2023 lengths on average, here's what we're seeing. So kind of mid North America, we've got some blue. There's some blue spots down in the southern hemisphere. There's all areas. Greenland, the warming hole area is a little bit lighter, and Pakistan area as well. So that means also that it's not growing universally the same everywhere. It's growing unevenly across the globe. And so I can also look at that start time. And you can see that the start on average, those same three plots. So 61 to 2023 Northern Hemisphere, 61 to 2023 Southern Hemisphere, and then 1990 to 2023 Northern Hemisphere. They're all decreasing. So they're all starting earlier because of that negative slope. So summer is starting earlier and summer is ending later. Same three plots again. And also I said that ocean should lag the start versus land, and it lags by about a month. That's the pink arrow on the right-hand side there. And also, the start and the end are not changing at the same rates. The starts, those negative values there are larger in absolute magnitude than the end. So spring is getting gobbled up faster than fall is disappearing and being summer. So a summary. Summer is growing dramatically in length across land, oceans, and coasts. And the rates are about the same. Ocean, land, coast, like the rate of change is about the same, even though the absolute numbers for lengths are different. But based on those trends, so if I was not born in the 60s, but my parents were. And so, you know, when I talk to them now about what I'm doing, I say, well, summer, based on the trends that we're observing, is about 40 days longer than it was when you were a kid. But if you were born in the 90s, summer is still almost a month longer. So the change is definitely skewed toward these recent years because of that faster rate. And that's an issue. It's yet another threshold phenomenon because we can have just kind of a inexorable linear increase in overall global mean temperature, but we are going to expand summer length. And so for some regions on the Earth where the range of temperatures is not as wide as, say, it is here in Vancouver, you could have some grid squares that are essentially become summer all the time in not too many years. So if the length of summer can change in a nonlinear fashion, even under a linear change in global average temperature, then of course all of these other interconnected phenomena can also change in a nonlinear way. Okay, that's kind of doom and gloom, but I thought I would add some fun to the IRES seminar. So we're going to play what I'm calling the summer games. This is audience participation, so get ready. Okay, so I want you to guess in which city, I'll give you pairs of cities, summers have lengthened the most. And we'll take a standard city battle, Vancouver versus Toronto. So yeah, sure, I'm happy to hear your guesses, but in your mind, think about, there's a map, Vicki, geographically what's going on, and maybe even think about some potential reasons why summer length might change more in one or other, or based on your own personal experience. Like if you're from this area, you've been to Toronto in summer, you might have some insight. But you had a thought. Do you want to? Yeah, let's hear it. Okay, so we have one audience member willing to put a chip in the Toronto. Changes the most, increased summer length the most. That baseline period of 61 to 90 versus now. Yeah, that's okay. Anybody else want to? Yeah. Oh yeah, yeah. Oh no, I'm no flashing back. You have to go based on your memory. Okay, so we got to vote for Vancouver as well. All right, well, here we go. I'm going to show you plots with median, and we'll compare those. And so Vancouver wins. In fact, these are violin plots, right? So we're getting the distribution, but we're also getting the median value. And you can see that the median value for Vancouver has changed almost twice as much as Toronto. Okay, now you're warmed up. Now, yeah. Now let's take that one that you just heard about having an enormous summer length this year. So I'm not including 2024 versus Beijing. All right, so one is considerably further north. There's water near both, but like, if you remember, we're basically near the Tropic of Cancer here. So anybody wanna put a stake in the ground? Yeah? Okay, Guangzhou. Now keep in mind, just to be very precise, remember their definition of summer is 5 consecutive days above 22 degrees. 22 degrees is not the 75th percentile temperature. So just when I show you the numbers, don't be shocked that they aren't 230 days. Anybody else want to put a stake in the ground on one of these two? Yeah? Median change. Yes. I appreciate that you're approaching it in sort of a lawyerly fashion. Yeah. Well, yes. Okay. All right, Guangzhou. Okay. Well, it turns out that they've both changed about the same, which I actually was shocked when I saw this. But yeah, just because of the headlines about Guangzhou this year. So the change was about 19 days for each. And in terms of percentage, they're still pretty close, but you know, yeah, surprising. Okay, how about this interesting fact? This is slightly an artifact of how I'm doing things, but the cities of 1965 and 1966 for Guangzhou actually had summers of length 0 because the entire year was below that 75th percentile temperature. So just in case anybody noticed that that violin plot went all the way to a summer length of 0, those are the 2 years that are referenced for that. Not true for Beijing. Okay, how about which city summer starts the earliest? Phoenix or New Delhi? Phoenix is the second fastest growing city in the United States right now. It's crazy hot there. Phoenix shouldn't exist except for the invention of air conditioning, for example. Anybody want to guess in which location summer starts the earliest? New Delhi, okay. Any takers for Phoenix? All right, we'll find out. It's New Delhi, by quite a bit, actually. And interestingly, not a significant change. In fact, if we look at medians, probably within the margin of error, summer hasn't changed in New Delhi versus Phoenix. Start has gotten quite a bit earlier relative to that baseline. I guess summer's gotten earlier for both, but, and because of Vicky, I included the dates. Yes, for day of year, because not everyone has 0 to 365 and knows what days of the month those are. All right, well, I hope that was fun. There are some other questions I can explore with these results. So you notice there was a change in rate of summer length as we look at more recent years. And in fact, if you look at more recent years, they're really falling off that linear trend. So there's some question about acceleration in summer length. Whether or not our climate models produce the same trends or not is interesting. Some of those prior works did look at, based on their data, again, was up to 2012, and they find that a lot of the global climate models do reproduce the trends, but they don't get that asymmetry in start versus end of the seasons. Also accumulated heat. So this would be like the integral of summer degree days. It looks similar to summer length, but it's definitely different and probably has a lot to do with what's going on locally in terms of land use and soil moisture and who knows what else. Timing of the day of max temperature. My advisor Rachel is here, and this is a very interesting question to her also. Like, is the day in which summer has its maximum temperature shifting, or is that staying about the same? And then how are all these changes being reflected in human populations? You know, are people moving to places where summers are longer or shorter, where heat is growing or shrinking? You know, they make choices based on a lot of reasons. May not have anything to do with this. Thanks. I didn't see any signs, Vicky, so I did okay. Good. Questions? Yeah. I see what you're saying. Okay, so the question was just to basically talk a little more about the 75th percentile as a threshold for summer. So yeah, so I get that threshold by taking the 75th percentile temperature of the years 61 to 1990. That gives me a fixed temperature number. And then I apply that threshold and I look at all the years. So that's why I don't just get 90 every time. And also that is kind of the standard that has done by others as well. There are a couple papers where they played around with what that threshold was, 50th percentile, even 25th percentile, which is, that's like the winter, you know, threshold. But they found that it didn't impact the trends. It changes the absolute lengths, but the trends that they got were about the same. Yeah. Yeah, sure. Again, I was sort of guided by those previous works because I wanted to begin by extending what had been done. So I needed to kind of snap to the methods that they were using. One difference is that I use, so ERA 5 can give you the daily mean. In some cases, you know, the other works, they would take the daily min and the daily max and then take the average and call that their mean instead. But you're right that like the minimum temperature is also really important for the human experience. You know, if temperatures don't vary that much, but that minimum is quite warm, your experience of summer is going to be, you know, unpleasant as well if it's really hot. But yeah, it was more of a methodological choice based on prior works and trying to sort of be able to be comparable to what they had done. Yeah. Yeah. Sure. Sure. I think, yeah. Oh, yeah. Right. Yeah. I think what you're getting at kind of is like using the term summer sort of, I don't know, ties us in to thinking about it in a certain way instead of kind of being flexible around like temperatures related to the threshold itself. Some of that is a little bit semantics, but some of it also is that the idea of summer is, you missed the first 5 minutes. Part of what I was talking about is the connection with human experience. And so summer is something that we talk about, we experience it as people, versus like, oh, it feels a degree warmer than I remember it being last year, and so yeah, that's the main motivation, and the fact that I'm trying to connect with these prior works that are looking at seasonal changes. Yeah, maybe. But I understand why. Yeah. Right. Yeah. Yeah. So yeah, you're asking like, summer is one thing, growing season is another thing. How do we reconcile these two, or can we extend it into thinking about the growing season? And there's a natural, obvious extension there. And some of the papers that I'm guided by are folks who are looking at the growing season specifically. Obviously, if summer is gobbling up the spring, and there are a couple papers that have looked at all four seasons, right? Spring is also eking its way into winter, so that is initiating that growing season earlier. But I'm not tying any of my stuff to phenology. I'm just really saying that, like, if we can see dramatic changes using summer kind of as a proxy, then we are going to see big changes in phenology as well. And other people who work on that area are reporting that. Yeah. But no, I am not going to start looking at that, I guess. Yeah. Yeah. Yep. No, you're okay. I just, there we go. Yeah. So like, the reason that I wanted to use a percentile definition and a threshold is that I can apply it universally across the globe, versus using an astronomical definition. And then, if you're in the southern hemisphere, things are different for your equinox time frame versus the northern hemisphere. Same as if we use a meteorological one. These are not flexible definitions, and I needed a definition that would let me say, hey, summer could be all year long if it has to be, or zero in the case of Guangzhou in 1965. Yeah, sure. Yeah. Yep. So the data is only as good as the data set. And so you're asking, like, how do I feel about ERA 5, being a mix of satellite data, observational data, and model data, to get those temperatures. And so it's the best available one for looking at something like this. And so that's why I'm using it. But I did also, just for fun, because you saw I was looking at the ocean, use some sea surface temperature data sets as well to see if I see the same trends, and I get the exact same slopes for air over ocean from those data sets. So that at least gave me a little confidence to like look outside ERA 5 at the ocean. Since others had not looked at the ocean, I wanted to at least look at a couple data sets. And since I saw kind of the same trends, that gave me some confidence. Yeah, the data is only as good as ERA 5, and ERA 5 is maybe the best one we have that lets me look globally. Some of the other papers that are out there, are like, how are the seasons changing for the United States? And then they will use observational data only. But if I want to look globally, I needed to use a global data set at high resolution. Yeah. Yeah. Yay. So the question is, are there noticeable shifts in the seasonal shifts that could impact ecosystems. And that's partly getting at what Naveen is asking as well is, if it is getting warmer earlier in a region, the, plants and animals key off of that. The insolation, the daylight isn't changing, right? But the temperatures are changing, and that still affects ecosystems, whether it's plants, opening up their stomata or whatever is happening to the organisms. Yes, the seasonal shift's certainly going to have an impact there. Yeah, and it's going to dry land out earlier, and that's going to, cause organisms that are looking for water to have to shift their habitats. And yeah, definitely. Okay, thanks. Yeah. So the math stats person is going to say that this decrease you're asking about, some of this is the fact that, remember, my baseline temperature is derived on 1961 to 1990. And so, I don't know, let's just say for argument's sake that that temperature is actually 1977's temperature. And if temperature had been increasing all along, then we might see a little bit of an artificial appearance of a decrease here. But like if you look at the ocean slope there, that's very steep. So it can't just be explained, I think, based on my methodology. As to what's going on there, I mean, the 70s are sort of the start of the big fossil fuel era, for one thing. And there's other larger scale climate variability stuff that kicked in at that time frame. Simon has told me about like the PDO shift. There's a few other, larger dramatic climate events that probably made things get warmer. And so that's also kind of underlying this as well. Maybe, yeah. Yeah. Thank you. Yeah, another explanation. Yeah. So yeah, another reason might be that we've weren't pumping out as many aerosols, and then suddenly we have all these additional aerosol effects, right? So, except that sometimes aerosols cool. It is the cooling due to aerosols? Okay, well, thanks. Which is also some of what's being argued for, if we pretend this is temperature, right? Most recent changes as well. Yeah. Thanks, Nimi. Yeah. I was going to say, you're going to make me go out of my lane if you want me to talk about geoengineering. But so I was just at the graduate climate conference. Oh, what's to be done about climate change? And so I was just at the graduate climate conference, which is held down in Washington State this year. And for one thing, I was shocked by the fact that about 25% of the presentations that were done there were about geoengineering. And some of them were critical of the idea, but in general, of the 120 grad students, if that's a representative sampling, we were all kind of talking about how the shift in mindset now is like, no, we really do need to explore these technologies, because while we may say we're keeping them in our back pocket, we might actually need them. And so we need to research the heck out of them to make sure we have our best understanding of what we could use. I would say that I don't love the idea of that, but it's not going to shock me if in my, my lifetime and my daughter's lifetime, she's a college student now, that like, that's where the debate is going to be going, is what techniques are we going to use and where are we employ them. And of course, this week it was just announced that the United States is initiating a program to try to monitor whether or not any geoengineering solar in particular is happening. So in other words, they want to be ready to detect it if some other country decides to just go their own, which is right out of Ministry for the Future. You know, that like some countries are going to say, that's it, you know, we're fed up, you know, we're dying, we're cooking, we're going to do it anyway. So I'm sure the US is not the only place that is trying to monitor for whether or not anybody's doing it. But my opinion is that we're probably going to need those methods. Yeah, you're welcome. Thank you for all those great questions. Yeah.